Hello. So, we will continue our discussion on the course on computer networks and internet. As we were last few lectures we are discussing on IP routing. So, today we will continue that discussion, and today we will discuss on BGP protocol, border gateway protocol. If you recollect that in the previous lectures or previous talks we discussed on two category of things, right. One is interior routing protocols and another is exterior routing protocols. So, the routing protocols which are within the autonomous systems and the routing protocols that is across autonomous systems, right. So, BGP or the border gateway protocol is this exterior routing protocol which helps in routing packets across autonomous systems, right. So, just a quick slide, that is a autonomous system. So, how we defined? It is a logical portion of a large IP network or the whole internet. An autonomous system normally consists of an internetwork within an organization control. That means, it is under one administrative control and it is administered by a single management authority like IIT Kharagpur can be a autonomous systems which is managed by the IIT Kharagpur authority or the cell which is handling those things. And an autonomous system can connect to other autonomous systems managed by the same organization or other organization, public or private. In other sense, our whole network is divided into several autonomous systems which consist of several networks, and there are routers or which takes care of the whole information of the autonomous system, that we have seen that there is a backbone area router or this backbone router which takes care of those type of things. So, our basic objective is to how if a packet from a autonomous system here wants to communicate to a autonomous system in some other place. So, how it will be routed. So, one is that there should be some internal routing protocol which will take care of this within the autonomous system, and there should be a protocol which goes across these things. If you recollect, so we talked about a path vector protocol which established a path between these different autonomous systems, right. So, it is a sequential set of autonomous systems, like I say that the packet 1 should travel by autonomous system 6, 8, 9, 10 or 6, 8, 9, 12 and so forth to reach the destination autonomous system. So, what we try to what we are talking about is routing protocol is one category is interior gateway protocols, IGPs, that is interior gateway protocol allows router to exchange information within an autonomous system. Examples of these protocols are OSPF and RIP. Predominantly used protocol is OSPF. Exterior gateway protocol EGPs, that is which follow a path vector protocol, and it allows exchange of information across autonomous system. So, one of the popular or the protocol for this EGP or exterior gateway protocols is border gateway protocol or BGP. So, today we will be, as we are discussing, is the basic feature of BGP protocol. So, BGP, as we are discussing, is an exterior gateway protocol, right. It was originally developed to provide loop free method of exchanging information between autonomous systems. So, there should not be any loop, right. BGP has since evolved to support aggregation and summarization of the routing informations, right. So, if you see that if we look at the whole internet or network of networks. So, there are in order to push this or any forwarding any information from one system or one network to another, it has to hop through several networks and autonomous systems, right. So, there should be some way of forwarding across autonomous systems, where we try to look at this BGP. So, BGP presently the popular version is BGP 4 is an IETF standard protocol. That means all BGP enabled devices or so called BGP routers or BGP devices follow a standard which allows it to route packets, right. So, if we look at the BGP components, so we see, so if this is a autonomous system AS1, AS2, so there are several things. One special device or things is or router is called BGP speaker, we will come to that. There can be several networks inside the things. Inside the autonomous system there are protocols called OSPF and RIP, which can be within the autonomous system. As each autonomous systems under single administrative control, so the administrator is free to choose which protocol to use, right. And if you again recollect, what we talked about, the autonomous system is again divided into different area. Out of that, one area is or area 0 is the backbone area, right, and there are other areas. So, that this backbone area or this backbone area router collects this information about this whole autonomous systems. So, it is those designated routers which takes care of the whole information base of the autonomous systems, and it does not mean that all all traffic of the area should go through the area border router or all traffic should go through that router, but what it means that it collects or it has the information about the whole autonomous systems. Now, the within across the autonomous system we have the protocol called eBGP or between the within the autonomous systems we have this protocol called IBGP. We will come to those things, right. So, let us look at some of the components. So, one thing what we have seen is the BGP speaker. So, it is a router configured to support BGP. So, a device or a router which is configured to support BGP is a what we say is BGP speaker. There are BGP neighbors or peers, that is a pair of BGP speakers that exchange routing informations are called peers, right. So, there can be two type of neighbors, the neighbors within the autonomous systems and neighbor across the autonomous systems. Accordingly, we have internal neighbor or IBGP, a pair of BGP speakers within the autonomous systems, and we have external neighbor or eBGP or a pair of BGP neighbors each in a different autonomous systems, right. So, if we again come back to this figure, so there is IBGP, this is the internal, that these are the two BGP speaker or two routers which are, there can be n number of routers within this particular autonomous systems. So, these are IBGP and these are eBGP, right. So, a pair of neighbors each in a different AS, these neighbors typically share directly a directly connected network, right. So, that is they are directly connected network scenario. There is a concept of BGP session, a TCP session connecting two BGP neighbors, right. The session is used to exchange routing information and neighbors monitor the state of session by sending keep alive messages. So, periodically send that keep alive messages, so that monitor the state of the other sessions, like. So, it is some sort of a pinging at after every or beckoning at a regular interval. There is a AS number for any autonomous systems, which is a 16-bit number uniquely defined a particular autonomous system. So, it is a so you can see that with the 16 we can have so many number of AS, right. So, it is a 2 to the power 16 number of AS are possible. That is quite a large number, considering that the ASs are having several routers, several network sources inside the things. There is a terminology or there is a concept of AS path, list of number of numbers AS number describing the route through the network, a BGP never communicates the path to its peers, right. So, that means, if I want to go from network say N11 of AS1 to network 62 of N62 of say AS6, then what are the path I need to follow, right. So, I start with a AS1 to AS3 to AS4 to AS6 or some other path type of things. So, it is a set of or sequential set of AS numbers which allow this routing within the network. Now, if we look at it, that there are, if we look at the BGP traffic, there are typically two type of traffic. One is local traffic. The traffic local to AS either originates or terminates within the AS, right. So, it originates or terminates within the, either the source or the destination resides in the AS. So, if the source or destination is residing in a AS, then the traffic for that particular BGP session we say that is a local traffic. Whereas, in a transit, any transit that is not local traffic is a transit traffic. That means, one goal of the BGP is to minimize the amount of transit traffic. That means, it is neither originating not terminating the AS, but it is passing through this AS, right. So, in other sense it is a traffic which is a load on that AS, so to say, right. So, it is one of the objective maybe minimize this type of transit traffic. So, there are a lot of transit traffic means you overload the things, right. So, and if we look at the AS types, so BGP defines primarily three type of autonomous systems, right. One is stub. A stub AS is a single connection to another AS, right. A stub AS carrying on only local traffic, because it's a one connection to the AS, but there is no other AS across that. That means it's a stub connection. So, that is only have local traffic. There is no transit traffic per se. There is a multi-homed AS. That is a multi-homed AS has connections to two or more ASs rather autonomous systems. So, however, a multi-home AS has been configured so that it does not forward traffic. So, a multi-home AS can be configured that it does not transmit say what we say transit traffic, it may drop or block and type of things. There is a transit AS. A transit AS has connection of two or more autonomous systems like multi homed AS, but carries both local and transit traffic. The AS that impose policy restriction on the types of transit traffic that will be forwarded, right. So, autonomous systems can be either multi-homed AS or transit AS. So, primarily the autonomous systems are multi-homed or transit. Stub is a special case of those scenarios. So, what we see that primarily two type of things are there. There is one is multi-homed and transit, though there are more than one connection, but in case of a multi-home you may not allow transit traffic, and there is a stub type of things where the where there is no there is only local traffic, either it originates or terminates. And as we understand, there can be policy as these are all path vector. So, I can have policy defined that which can be transit through the things and like that, right. So, there can be restriction on which sort of AS it should pass type of thing that you allow it to transit the traffic. There are few more concepts. One is that routing policy that is important, the set of rules constraining the flow of data packets through the network, right. That is the what we look at the routing policy. So, routing policy are not defined per se in BGP protocol, rather they are used to configure a BGP device, right. So, the in other sense while I am configuring the BGP device, I embed that policy into the thing. For example, a BGP device can be configured so that a multi-home AS can refuse to act as a transit, right. So, that is a policy that I will not allow. This is accomplished by advising only those networks which are either terminating or originating that AS, right. So, it is confined within that particular AS. So, a multi-home AS can perform transit AS routing for restricted set of agent autonomous systems. It does not does this by advertising or by tailoring the routing advertisement to send to the eBGP papers. In other sense, what it tries to say that it while advertising that routing information to the other eBGP routers. So, what it does a tailoring of the things, that means it modifies the things in such a way that which is within its policy paradigm, or an AS can optimize traffic to use specific AS path for certain category of traffic. Like I say, I get a traffic of streaming video or a particular type of traffic, then it says that it should be channelized through a particular path. So, it can be configured or channelized through a particular path. So, that can be one such policy type of things. There is a concept of network layer reachability information. Network layer reachability information also known as NLRI. So, NLRI is used by BGP to advertise routes, right. So, it says that what is the network layer information. So, it consists of a set of network represented by a tuple, that is length and prefix, like it says that tuple 14202, that one example represent that the CIDR route as this so and so forth, right. So, it is network layer reachability information, that means which ports which portion or which domain of the network you can access, right. So, that is in this case that /14 is the thing. Routes and paths with respect to BGP, a route associates a destination with a collection of attributes describing the path to the destination. A destination specified by NLRI format. The path is reported as a collection of path attributes. This information is advertised by the update things. So, now how do I route I define? It's a defined by a set of AS. How this AS is defined is by a set of path parameters, right. And the destination of the things where it will go, because when it goes through this BGP router, it need to know that where the destination is, that is in that NLRI format, and it goes on this it basically takes these path attributes along with the things, right, through which which ASS it will hops, and when that this advertisement is for this advertisement, this update message format or the update message protocol is used in the BGP. We will come to that what is update. Actually, we discussed little bit of what are the different type of BGP formats, and that update is there. Anyway, we will discuss again. Now, so we have eBGP, external BGP to communicate with the across AS, iBGP to communicate within the AS. So, we have eBGP, iBGP communication. Finally, to make this happen, so if you see, it is not only external, right, once it enters, it go on hopping with the networks and go through some other router to the type of things, right. And this paths is also there are BGP with for the external, and there are OSPF, or what do I say, that internal protocols are IGP protocols are running, that OSPF every protocols are running. So, there should be a proper coordination between them, right. Otherwise, the packet forwarding will not be possible, right. So, BGP does not replace IGP operating within the AS. So, it is not like that it replaces OSPF or RIP type of protocol, right. Instead, what we are saying, coordinates or cooperates with the IGP to establish communication between the autonomous systems, right. So, BGP within AS is used to advertise the local IGP routes, right. Within the AS, it has to advertise the local IGP routes, because within the AS, that is the predominant, right. These routes are advertised to BGP peers in other AS, right. So, this has to be known to the BGP peers in the other AS. So, what we look at the communication. So, role of BGP and IGP. So, both BGP and IGP, that is border gateway protocol, and that the internal gateway protocol, that is OSPF and RIP, are used to carry out information, carry information through an AS, right. So, otherwise how the packet will be forwarded. Establishing TCP sessions between the two pairs. Before establishing a BGP session, the device verifies, that BGP device verifies the routing information is available in each pair. So, it should be available in each pair. eBGP pairs, that these eBGP pairs typically share a directly connected network. So, this in case of a eBGP pairs, as we discussed couple of slides back, it typically share a directly connected network. The routing information need to be exchanged by the BGP packets between these pairs is trivial, right. It is directly connected thing. If for IBGP pairs can be located anywhere within the AS. So, they do not need to be directly connected. BGP relies on the IGP, that is the internal gateway protocols, to locate a pair. Packet forwarded between the IBGP pairs uses a IBGP LAN routes. So, that means the what we mean to say, that OSPF or RIP protocols, whatever it is LAN, that those are those information are being used by this BGP. So, full mesh BGP sessions within the AS, right. IBGP speakers assume that a full mesh BGP session has been established between the pairs in the same AS, right. So, it is a full meshed BGP session. So, everybody knows, or everybody connected to others. So, it is a full mesh connection. When a BGP speaker receives a router update from a IBGP pair, the receiving speaker uses the eBGP propagate to update the external pairs, right. Because the receiving speaker assumes full mesh IBGP sessions have been established, it does not propagate the update to the other BGP pairs. So, as this is a full mesh, so the full mesh IBGP sessions have been established, it does not propagate to the update to the other, because it knows that the update has been taken care by this full this particular way of connectivity. So, the same thing what we were discussing. So, if we have, so there are several BGP routers. So, there is a IBGP protocols which are connected across the thing, and this when this protocol BGP this BGP device R6 connected to the BGP R1 through the IBGP updated to BGP R3 and goes like that, and so forth, right. So, that is the way of connectivity. Now, as we mentioned earlier, so what are the different BGP packet types, right. So, one is open, other is update, notification, keep alive. So, these are the typical 4 type of packets which the BGP has. The open is this message type establish a BGP session between two peer nodes, right. So, this is to establishing a BGP session between two peer nodes, that is the open. Update, this message type transfer routing information between the BGP pairs. So, there is a typo, it should be BGP pairs. So, this message information that is update is basically routing information from between the BGP pairs. Notification, this is when a error occurs is detected. So, if there is an abnormal situation, so it requires a notification of the thing. Keep alive, this determines if the pairs are reachable or not. So, it is some sort of a beckoning type of things which goes on things. So, one is the opening the session between the two BGP pairs. Another is the update, updating routing information across the BGP pairs, right. Another is what we so there is again a typo, it should be notification, in this here it should be notification. So, then another message is a notification, this message is sent when an error occurs or error is detected, and then other is the keep alive, that is the beckoning to say that the pairs are reachable or not, to determine whether the pairs are reachable or not, we have those things. Now, if we look at the different functionalities. One is opening and conferring BGP connection is the functionality. Primarily after a TCP session has been established between the two BGP peers, each router sends a open message to the neighbor, to its neighbor. That is the opening and conferring BGP connection, as we mentioned earlier, that is establishing the connection. Another is maintaining BGP connection. So, one it is open and thing is there. Next is maintaining the BGP connection, that BGP does not use any transport layer keep alive to determine if the peers are reachable or not. Instead, BGP messages are periodically exchanged between the peers, right. If no message are received from the peer for a duration specified by the hold time, that hold timer, the originating router assume that an error has occurred, right. When this happens, the error notification is sent to the things. So, it is go on beckoning between the peers whenever it is not receiving within a particular time period. So, it goes on a it thinks that the BGP, that the peer BGP device is not responding, and accordingly a error notification or error or a condition is generated and the information is sent to the things. Sending reachability information is exchanged by the update message, right. As we seen that reachability information is primarily finding that more that is the routing information. If there is a information change in information or update in the reachability information, it is exchanged between the peers in the update message. So, update message is used to advertise feasible routers to or withdraw infeasible routers. So, both advertising the possible feasible routers and withdrawing infeasible routers. So, notification of error conditions. A BGP device can observe error condition impacting the connection to a peer. So, that means it may not be responding or some other error situation arises. So, notification message is sent to the neighbor when the conditions are detected. After the message is sent, the BGP transport connection is closed. This means all the resources for the BGP connection are deallocated, right. So, that means once it is notification sends, the particular connection to that particular BGP peer or the device is closed, and the resources provisioned or allocated for that things are released, right. So, the routing table entries associated with the remote peer are marked invalid. Finally, other peers are notified. So, you see, so once we see that the connection with one BGP router or the peer device is there, this is notified and the connection is closed, all resources are released, and now it has a new update, right. So, it has to find a new path and it is being advertised to the other or marked as invalid, that particular path, and it is advertised to the other peers, right. So, that is important. So, there are other things like BGP selection. BGP is a path vector protocol, as we discussed. So, in a path vector, the path is expressed in terms of domains or confederations transferred so path, right. So, path has to be defined how. So, path is defined a series of A's within the properties and type of things or which domain it is hopping through. The best path is obtained by comparing the number of domains of each feasible routes, right. So, one is that how many domains need to be hopped. There is no universal agreed upon metric that can be used to evaluate the external path. So, that is important, that is difficult, because each A has its own criteria of path evaluation, right. So, there is no universal metric because it is a large network, right. It is a large networks of networks, and there are several A's. So, each A has their own way of finding the optimal path. So, which is based on the path attributes. So, there are several path attributes are used to describe and evaluate a path. PRs exchange path attributes along with other routing informations. So, when a BGP router advertises a route, it can add or modify the path attributes before advertising the route to a peer. So, once a BGP router receives this update, then while updating the things, it can basically update the path attributes before transmitting it to the peer. The combination of attributes are used to select the best path, right. The combination of attributes are used to select the best path of the things. That means, what we want to say, this your path is defined by these several A's, which are in turn defined by the attribute set of these A's, right, or that particular path, and which can be used, which these attributes values are used to find the optimal path based on the based on the policy of the given A's. So, there are we also discussed in earlier thing, we will go quickly, that is there are 4 path attribute categories, as we have discussed in the path vector protocol. One is well known mandatory, the attribute must be recognized by all BGP implementation, is must be sent for every update message. This is a well known and mandatory. Well known discretionary, that is the attribute must be recognized by all BGP implementation, however, it is not required to send for every messages. So, it is a discretion or discretionary. Optional transitive, that is it is not required for every BGP implementation to recognize this type of attribute, right, it is optional, but a path with a unrecognized optional transitive attribute is accepted and simply forwarded to the BGP peers. So, it is if it is unrecognized optional transitive attribute, that means it is being transmitted to the peer without doing any analysis or without taking any call on it, right. Optional non-transitive, if it is not required for every BGP implementation recognize this type of attribute, these attributes can be ignored and not passed along with the things. So, it is one is optional transitive, that means it is optional, but it may not recognize, but it can transmit. Another is optional in non-transmitted, if it is not recognized, or it can be ignored and may not be transmitted to the other side. And if we look at that a previous lecture or previous lecture we discussed. So, what we see that this is the N1, R1, S1, this is the particular reachability of the things. So, in order from here, if I want to see N1, R2, N1, R2, AS2, AS1 is the path, and so on and so forth. So, where from this R4 we see this is the AS3, AS2 and AS1, and then a next router is router 3 and the destination network is N1. So, next router 3, then AS3, AS2, AS1, and then you have the router. So, this is the way the paths can be defined, and for different network what is the next router and paths can be defined. So, two quick concept, one is the BGP aggregation. So, a major improvement in BGP version 4 for CIDR and route aggregation. So, that means the feature allows BGP peers to consolidate multiple contiguous routing entries into a single advertisement, and it significantly enhances the scalability of the BGP to the large network. So, I can contiguous routing advertisement in a single entry, and in doing so it basically helps in scaling the things. There is another concept called BGP confederation. So, BGP requires all speakers within the single layer have fully meshed set of BGP connections, right. So, if it is it basically this creates a problem in scalability. If there are large number of speakers within the AS making this connection, and if it is dynamic, then making and breaking these connections become a major challenge. So, I can have different sub AS sort of things within the AS, right, or what we say that is a confederations of AS is there, right. So, a BGP confederation creates a set of autonomous systems that represent a single AS, right. So, AS1 can have different AS1, 1, 1, 2 type of things, and to peers external to the confederation. This removes the full mesh requirement and reduces the manageability, because the full mesh requirement is now confined within that particular AS where or sub AS type of things or confederation is maintained. So, in this way the manageability may be made much or scalability is facilitated. So, what we see in try to or what we discuss today is that different feature of BGP routing protocols, how it can be defined, how path is defined, and so on and so forth, how it helps in sending a packet from a particular network in a particular AS or autonomous system to a other AS in the autonomous systems, right. So, we will continue our discussion on this computer network and internet protocols in the subsequent lecture. Slowly we will look at other layers, or as we are following a top down approach. Now, we will look at the other layers at the on the TCP/IP model. So, with this let us conclude our discussion today. Thank you.